Okay, let us see how we can go about this proof here. It's a nice one also. The particle is projected vertically upwards from the ground with the speed of this and clears the top of the cliff of a vertical pole of height h. So this is our pole here. So the height of this pole is h. So we are throwing it down from here, then it clears. So you see, it clears off this in this second. So from here up to here, it's going to clear from here. What we are throwing is going to clear that in t seconds. This velocity it's using is m, is u meters per second. So they're giving us a particle is projected vertically upwards from the ground with the speed of that, and clears the top of the vertical pole of height h. This is now the vertical pole in this seconds, and returns to the pole in half t seconds later. So it means that after clearing here, this thing is going to continue going upwards. Then when it reaches there, it will fall back like that. Now, they are telling us that and returns to the pole, to the top of the pole in t. So meaning from here up to here, it has used t from here up to here, returning back. So here it has used t over 2 seconds. When they are asking us, show that this is true. Now, how do we handle that question? Yeah, you have to be a lot very careful. So first of all, we have this pole. This is our pole, and this is our pole. So now it's of height h. Now first of all, we have this distance and we have this time. So you know that our s is equal to ut. Now that's going to be half at squared. First of all, our acceleration here is going to be negative v because it's going up and it's opposing gravity. So we have our t as t, we have our acceleration which is there, negative, and then we have our s as h there, the height, the distance. This is going to cover there. So we have now h equal to u t minus, because our s negative, half v t squared. I call this equation 1. Now, in our proof and look in our proof, you don't have anything like t. So what I'm doing, I'm trying to eliminate t. I need 2 equations. So that I can eliminate this t. Now, in the second part, that's where common sense is going to come in. Now from here up to here, it's using 2.5 seconds. But from here up to here, this particle has covered 0 distance. Why? Yes, you can say there is some distance covered, but in terms of, you see, it's going, then it's coming back. So there the distance is 0. How do I explain this? You look at this. When I have this box here, when I lift it up here, it has covered some distance. Then I bring it back. The distance covered is 0. In simple terms, like you move one step forward, then you move one step backwards. You have covered, in simple terms, you have covered 0 distance. You are remaining in the same place. So when I put this box here, then there's a distance, then I bring it back. So the distance covered, they ask what distance has this box covered, is you tell me 0. Why? Now, when you come to this particle also, coming up here, then you see this is the top. So going here up and coming back there, the distance covered is going to be 0. But now, so mean that from here up to here, this particle has covered only this distance, h. Because this one from here up to here is covered here, then it's coming back, so it's 0. So meaning, from here up to here, it has covered only h. Okay, I think you've got that. Now, so the other idea, now note, after Okay, the time here I'm going to use is t plus a half t seconds, comma, the particle covered h plus 0 meters. And the 0 is this, the 0 meters. So from here up to here. So there we are adding the time for this, and then the time for the whole of that, which is t plus this. So for the t, it has covered this, then for this, it has covered the 0, because it has moved and then it has come back. So that's what we have there. So meaning now, if now I use s equaling to t, my plus half 8t squared. Here now my 8 is going to be 8 plus, so the distance covered is going to be 8 plus 0. So I'm adding 8 plus 0 equaling 2. Now my time is going to be t plus a half t. Then minus a half g into t plus t over 2 squared. So this distance here, I mean the time here, we add this plus that there. So there is that our 8 is going to be equal, this will be 3 ut over 2, then minus, when we have here, we have a half d into 3t over 2, the whole squared. So to simplify that, is that our h from there is going to be 3ut over 2, then minus a half g. When we square this, we get 9t squared, the whole over 4. So which will be 3 over 2 ut minus 9g t squared over 8. And I call this equation 2. So now you know that equation 2, this equation 2 is equal to equation 1. So now that our 2 is equal to 1, so h is equal to h. The h here we have the 3ut over 2 minus 9g t squared over 8 equal to now the first one, which is ut minus a half g t squared. As simple as that. So if you multiply through by 8, I'll be having now here by 8 through by 8, I'll multiply here 8, I'll be having now 12ut minus 9g t squared equal to 8ut, then minus 4g t squared. Multiply through by 8. So we are doing multiply through by 8. Okay, and then now simplify. What do we now in my students, I want to make my t the subject. So when I bring this to side, I'll be having 4 ut equaling to, when I bring this side, when I make this side, I have 5 dt squared. So when I bring everything one side, okay, you know that this will be the same as 4 ut minus 5 dt squared equal to 0. Factorizing out t, so see I be having 4u minus 5 dt equal to 0. So either my t is 0 or my 5u minus 5 dt is 0. Now, from here, you can see that therefore, you can see if I make, this is 4. You can make t the subject, so that my t is going to be, so 4u equaling to 5 dt. So that from there, so that our t is going to be 4u over 5g. Now, after getting our t, what are you going to use it? We shall put it into this formula. because it's that in our proof we don't have anything like t. So when I put it in this formula, so my h equaling to ut minus half g t squared. Putting now our t, we have u into 4u 5g, then minus half into, so this is a g, it is a g, this g, then 4u over 5g the whole square. So what happens if we simplify? Which would be the same as, this would be 4u squared over 5g, then minus, now this is going to be g over 2 into now 16u squared over 25g squared. So that this one can reduce this by 8. So you start the LCM. What do I have up and see that? We are going to see that the LCM is going to be 25b. Is it? 25b. Our LCM. This one here. So, okay, let me finish so that people can see. Over 5g. Then minus, this is 8u squared over 25g. So it's the LCM. So this goes here 5 times, this goes here 5 times that, I have 20 u squared, then minus, this goes here, I think you can see it's going just there once, times that we have 8 u squared, which will be, now this will be what? When you simplify that, this is that we shall be having 12u squared over 25g. And it was multiply this here, so we have our 12u squared, and it was multiply this, now we have 25hg, and I think it is our proof there. So the proof is that in there. So part B, its speed, show that its speed is that. So what is our speed? So in our part B, allow me to use this as for the last part. So part B, prove that the speed at the top of the pole is this. What is the speed at this top of the pole? So the speed at the top of the pole. So let us see what we are going to be having here. So at the top of the pole, what is happening there? You see that our p is going to be u plus 18. Our velocity is going to be the u, the initial, then acceleration is dt. So from here, now I'm going to substitute in my t because I have my t. So if this one was equation maybe 3. So from 3, my b is going to be u minus dt, which will be u minus d into, now my t which is 4u over 5g. That's this g, will cancel. I'll be having u minus 4u over 5. And when you simplify that, so that our b is going to be, this will be 5. Okay, this will be 5u minus 4u the whole over 5, which will be u the whole over 5. And that will be the proof there. Meters per second. That will be our answer there. So that's why we had to handle that proof with ease. I think you can see that now. This is there and that's there. The idea is you don't confuse from here up here, there is no distance covered. Yet the time was increasing, so when we add this t to this, we have 3 over 2t. Remember, distance we have covered. Coming here and coming back, from here and then coming back, we have covered 0 distance. You have gone, then you are coming back 0 distance. Yet the time was increasing. That's why the time is going to increase. The distance we are covered is not going to be there. Blessed members, I wish you